Good day, grade 12 learners and teachers. Welcome to today's mathematics lesson. My name is Mr. Shongwe, and this lesson is brought to you by the Gauteng Department of Education in collaboration with the Saibono Discovery Center. Right, welcome you to the term. We hope that you've gathered enough energy and strength for term 3, which is a very short term. So we need to make sure that we finish the remaining content, 3 topics, and then from there we prepare for our preparatory examination. So today we're just going to focus on annuities. I'm aware that most of you have covered this already because according to our provincial request, we're supposed to do it during the holidays, okay? So now we're just going to be looking at revising some of those concepts on annuities. So I'll need you to bring your A game because there are activities that I'll be giving you, and I hope that you are able to do those activities as quick as you can, because we'll try to cover as much work as we can that will prepare you for your preparatory examination. All right. Okay, so let's go on with our lesson. Let's look at today's objectives. Okay. The first one, we have to revise formulae that are used in grade 10 and 11 finance, growth and decay, okay? And then we need to then understand what annuity means. When someone says it's an annuity, what does that person mean? So we'll look at the concept of annuity in the context of mathematics and finance, okay? And then we will then look into the future value annuity. What is it? And when is it useful, the future value annuity formula, okay? And then we are going to look at the formula, and we are going to perform calculations on the future value annuity formula, as well as look at some of the slight deviations or adaptations that can be made to the formula based on certain conditions, all right? And then we are going to also look at the meaning of present value annuity so that we understand what it means when someone says it is a present value of a specific annuity, all right? And then we are going to go through the formula of the present value annuity, and then from there we are also going to perform calculations as well as dive deeper into the context of present value annuity, where we have different loans, we have missed payments, we have outstanding balance in a particular loan. So we're going to look deeper into those things, all right? You can make reference to the CAPS document as well as the exam guideline just to find out the scope within which we have to operate as far as finance, growth and decay is concerned, all right? The pages are outlined there, all right? Now, what is it that you should be bringing into this particular lesson? The pre-knowledge that you need to have. A geometric series, okay? This knowledge of geometric series helps us. It helps us to derive formulae for future and present value annuities. All right, annuities. So that is where this geometric series comes through, because this money, as it grows, as you keep on investing the same amount of money, or you keep on paying the same amount of money at a regular intervals, then you get to generate a series which would be geometric, all right? And then that series is then going to be used, all right, to derive the formula that we use for future value as well as for present value, okay? Simple interest, compound interest, linear depreciation, and reducing balance. This is from grade 11, all right? This is knowledge from grade 11 that you need to bring into the current lesson, all right? Nominal and effective rates, you know the formula to convert between nominal and effective rates. But remember, sometimes you have to move from nominal to nominal. Then you need to know how to derive formula for that. It's very, very important, okay? And then timelines, they are at the center of this particular topic. Without thorough understanding of timelines, good people, it will be very difficult to answer questions in finance. Very, very difficult. So a timeline is a useful tool, a very useful tool that makes things easy because you are able to visualize and see these amounts as they move through the timeline so that you are able to perform those calculations. So please make sure that you grasp and understand the use of the timelines. All right. So we are moving on now. We have a baseline assessment. This assessment is just aiming at finding out whether the things that I've mentioned here, all right, I've mentioned things here on the prior knowledge, all right. So the baseline assessment comes in then to check and ensure that you do remember those things as we are about to start our lesson. Okay, so I am going to give you just 4 minutes, okay, 4 minutes to answer these two questions. All right, it's number one and number two. Please answer both of them. I'm just going to give you 4 minutes to do that, and your 4 minutes time starts now. Right, hello and welcome back. I hope you were able to effectively answer both these questions. I'm just going to take you through the solution sets for both of them. Okay, please remember we are available on our WhatsApp interactive line on 06474898913. I think it will pop at the bottom of your screen. Please, when you have questions based on the current lesson, do send us those questions, or if you don't understand the specific concepts that we just spoke about, please make sure that you do ask those questions so that we can assist. All right. Temba invests 10,000 for 4 years at 7.5% per annum compounded monthly. Determine the value of Temba's investment after 4 years. All right. So that's the first question. So we are given an amount of 10,000 that is invested. We are given the duration of the investment and the interest rate with which the investment is growing, and you are also told that it is compounded. So because of that, you know you are dealing with compound interest. Determine the value of Temba's investment after 4 years. So he's investing, so you are expecting to have that the amount that Temba will have after 4 years should be greater than the amount that he initially invested, okay, because of the interest that it earns. And this interest grows on top of interest. So it is compounded, all right? So it's compound interest. So let's look at the solution set for that, okay? First things first, we are going to use the compound interest formula, but you can see that there are slight variations here because we are compounding monthly and we are doing it for 4 years, all right? So this M here represents what now? Those compounding periods, okay? So the M represents the compounding periods. To say we are doing it monthly in as much as the investment period is annually, all right? So let's check here. Substituting, we have 10,000 as the present value, all right, or the principal amount, or the present amount, and then we have the percentage here, so it's converted, all right. This is 7.5 converted, so we take that 7.5 divide by 100 so that we convert it to what we call the fractional interest rate. Rather than being R, it is now changed to I, which is the fractional interest rate, all right? So 12 represents the compoundings. If we are compounding monthly, so we do it 12 times a year. And then it means that in 4 years, we would have done it 4 times 12 because we are doing it every month, okay? So we would have done it in 48 times, all right? So putting that in your calculator, you get that the amount is 13,485.99. So this would be the accumulated amount, right? So that is the money that Temba will get afterwards. Remember, sometimes they can ask how much interest did Temba receive. So you just subtract the 10,000 from the 13,485.99. All right, so you'll get that the interest is 3,485.99. So that's important. They are asking for the interest. All right, now let's move on to number 2. Convert an effective annual. So the question here wants us to convert an effective annual interest rate of 12% per annum to a nominal interest rate compounded quarterly. All right, so we are converting an annual interest rate to a nominal rate that is compounded quarterly. Remember, nominal rates have different compoundings, all right? So now let's look at what we should be doing here. This is the formula that we use. Remember, this is not in the formula sheet, all right? Not in the formula sheet. Not in formula sheet, okay? So it's a formula that you need to know, right? You can obviously derive it by equating the two future values and you'll be able to get to it, all right? I'm not going to do it now, but that's how the formula has been derived, all right? Because the two future values would obviously be the same. So we can equate them and then we eliminate those variables that are the same. We end up with this particular formula here. All right, so this is the formula that we have. Effective rate we are given. All right, so let's substitute now 0.12 as the effective rate. We want to convert it to a nominal rate, so this is the unknown. All right, The compoundings, they said quarterly, so we compound 4 times a year, all right? We compound 4 times a year because we compound every 3 months. That's what quarterly means, all right? So now, to simplify this, what we can do here is we can take the 4th root, because this is to the power of 4. So we can take the 4th root both sides. So if we take the 4th root here, we would have the 4th root of 1 plus 0,12, all right? This would be equals to 1 plus I nominal divided by 4. Now, if you make I nominal the subject of the formula, it means you have to transpose the 1. That's where the minus 1 comes from, all right? So if you transpose the 1, you'd get the 4th root of 1 plus 0,12, which is 1,12, subtract 1, all right? This would be I nominal divide by 4. Then you are going to multiply both sides by 4, right? This is algebraic. You're just manipulating the formula. So I nominal in this case becomes 0,1149. Remember, this is the fractional interest rate, so we want to take it back to the interest rate, okay? So the nominal interest rate, we multiply this by what? By 100 to convert it to what? To convert it to R nominal, all right? So after multiplying by 100, we get that it is 11,4549%. So you can see if they are saying 12% per annum compounded quarterly, it means that the actual interest rate is 11,49, all right? It's 11,49 if you want to calculate the nominal interest rate for that, all right? Remember, at the end, it gives you the same future value, all right? Fine, that would be our baseline assessment. Let's move on now. Let's start our actual work here. Revision of grade 10 and 11 formula. It is necessary before we get to our actual work on annuities that we revise some of the formulae that you worked with in grade 10, all right, and grade 11 as well, okay? The first formula, this is for simple interest, okay? You can see here I did actually try to actually explain this, that this is the formula for simple interest, which is linear, all right, which is linear. So if you can draw the graph for this, you will get a straight line graph, all right, an increasing function, because this is interest that is gained, all right? So you get that the function itself here is going to increase, all right? It's going to increase, okay? So you have an increasing function. I'm starting here, that is if I started investing a certain amount of money X there. So as the money grows, that grows linearly, okay? All right. Now, this is the next formula that represents now the linear depreciation, all right? This represents the linear depreciation. That is, if now the money that you have there is reducing, all right? It is reducing, just like your cell phone, all right? The cell phone that you have, if you buy it now and you want to sell it later, together with a car and furniture as well, the value decreases, all right? So if the decrease is linear, then it is governed by a linear depreciation formula that is simple interest, all right? So this is also linear, but the graph now will then be, instead of being an increasing function, it will then be a decreasing function, all right? But it is still linear, okay? So now this is compound interest, okay? So this is your compound interest formula. This one is exponential, okay? The graph itself is exponential, okay? But it is an increasing exponential function, all right? It is an increasing exponential function. I can actually show it here as an increasing exponential function, all right? Without wasting any time, this is the reducing balance. This is also an exponential function, but it is a decreasing one because the balance there becomes reduced, okay? So it is a reducing balance depreciation. It is an exponential function, but it is a decreasing function. Now, I need you to be able to go back and check on questions that infuse graphs here, all right? Please make sure that you also know how to answer those questions. where graphs are drawn, either linear or exponential, and at times they draw both of them on the same set of axes like this, okay? So you need to be able to know how to analyze them. Please go and look at those questions that infuse that, all right? The last formula here is the one that we use to convert from nominal to effective. But remember, I said to you, sometimes you have to move from nominal to nominal, okay? So you will need to have another formula for that one. Remember now, this is changing from nominal interest rate to effective interest rate and vice versa. Sometimes you have to move from nominal to nominal. That is where you will say 1 plus I nominal 1 upon M1, all right, is equals to raise what? Raise M1 is equals to 1 plus I nominal 2 divided by M2. This is upon what? M2 to the exponent of M2. This is now to move from nominal to nominal, all right? From nominal to nominal. So it's a formula that you need to know. But remember, both of them have been derived from the compound interest where you've equated the two, all right? So you need to know how to work with those formulas. But at times, learners choose to move. If they want you to move from a nominal to nominal, you find that the learner would convert the first nominal rate to an effective rate and then move that effective to another nominal. So it allows you to do that, but this formula that I've just written will take you straight there, all right? Let's move on. Let's look at the parameters here. A is the final value, and then P is the original value, the invested value, all right? I is the fractional interest rate per compounding period, okay? And then N is the number of periods. I'm trying to explain the parameters that are in these equations, okay? And then I effective, that is the annual effective rate. And then I nominal, that is the nominal interest rate, okay? So those are the explanation of each parameter that is in these equations, all right? So these are things that you already know from grade 10, all right, and 11, okay? So now let's go to annuities. Now I want to take you through the background of what it means when someone says, I have an annuity. We are talking to this in the context of mathematics and in particular financial mathematics, all right? In grade 10, you learn how to deal with individual payments and withdrawals separately to perform calculations. That's what you were doing in those timelines in grade 10 and grade 11. What if the same amount of withdrawal is made at regular intervals, all right? Underline same amount, regular intervals, all right? For a long period of time. Okay, for an example, a parent is saving for his child's university fees and investing 1,500 monthly for 10 years. You see, this is the same amount and it's invested every month, all right, for 10 years, all right? So it's the same amount, 1,500 invested every month for 10 years, all right? So another one, a house is bought and the payment to the house is 6,500 monthly for 20 years. So you can see the regularity is the same, all right? Monthly. And the amount that is invested is also the same, all right? So if you have that, you have the investment periods being the same, all right? And also, or rather, the payment periods being the same. And you also have that the regularity with which they are paid is the same, monthly, same amount, monthly, all right? You get that you develop what we call now an annuity, all right? So we need to understand it from that particular context, all right? Now, let's continue with our background. Given the two examples, special formulas should be used to accommodate these payments in one single calculation. These formulae are known as the annuity formulae, all right? So we develop formulas to enable us to deal with this new problem that we've presented. In grade 10 and 11, different amounts, withdrawals, and what you call investments within a specific time period. So in grade 12 now you have that you are moving with the same amount in the same what you call period of time. All right, so we develop the annuity now, which now we have to know how to deal with using the annuity formula. All right, so we'll cover two types of these annuities. Number one, it is the future value. Number two is the present value annuity. All right, let's go through. All right, so we are continuing with our annuities. Now let's define it formally. An annuity is a series of equal payments made at regular intervals. All right, equal payments made what? Regular intervals for a certain amount of time. An annuity is subject to an interest rate. All right, examples of annuities involve regular savings, all right, retirement annuities, home loan repayments, vehicle loan repayments. This is something that you know, it's something that is happening in our everyday lives, all right. The annuity formula you'll be using in grade 12 are based on the following. So these are what governs the annuity formulas that we are going to use in grade 12. Remember, this section is very, very broad. Those of you that will study finance even beyond beyond high school level, you'll get to see that these formulae here, they go deeper than what we do here. So, but in the context of what we are going to be using here at this particular level, these are the following important things which the formulas that we use will be based on. Number one, all payments are equal, all right? All payments are equal. If they are not equal, then we have what we call a variation to the formula. So you need to be able to account for that variation, all right? So all payments are made at regular intervals. If it's monthly, should always be monthly for the whole period. If it's not, then you need to apply your knowledge of nominal and effective rates to convert so that it is aligned to the regularity of investment there, all right, or the regularity of the payments, okay? The interest rate remains fixed, all right? The interest in grade 10 and grade 11, you got to change interest rates as you are moving. But here now, to use this formula, all right, to use this formula, you must have an interest rate that remains fixed for the duration of the investment. The compounding period of the interest is the same as the payment intervals. Let me explain this one, very, very important. If we are saying the compounding period of interest is the same as the payment intervals, it means if you are paying monthly, all right, then you should compound monthly, all right? If you are paying semi-annually, all right, every 6 months, then you should compound semi-annually. If you are paying quarterly or investing quarterly, then you should have that the compounding should also be quarterly. If it's not, then you have to convert. All right. If your interest rate is quarterly, all right, but you are paying every month or you are investing every month, you got to change that interest rate using what? The conversion from one nominal rate to another that I showed you in the previous slide when we were still revising. So that's very, very important. It's key. It's key because otherwise this formula will not work. All right? Otherwise the formula will not work. Okay? The final payment is made at a time that the total accumulated amount is calculated. Normally, I would say the formula works to the last payment. So if you have your timeline and you are putting in amounts here, if you are withdrawing here, you should make a payment. That is the assumption that the formula works to the last payment. So if you are withdrawing this month, then the assumption is that you should also pay that particular month. That's how these formulas should work. That's not how it works practically. If you look at it, you have invested money and then you want to take it out, then they are saying before you take it out, you should pay. So that's not does not make sense in our everyday running of things. But in order for us to use that formula, we should actually have made that last payment, all right? So that's very, very important. It means that the final amount does not earn any interest. That's what we sometimes say. We sometimes say the formula works to the last payment, or we say the last payment does not earn interest, okay? Right. Now let's look at the definition of the future value. See, now we have just spoken about annuities in general. We are zooming into those annuities now. We are looking at the future value. Definition: the future value of an annuity is the total capital, including interest, that accumulates by depositing equal regular payments into a savings or an investment account. So future value, we are saving. All right. So let's look at what I wrote here. The purpose of future value annuity is to save money for the future. All right, you are saving. All right, it's different when you have borrowed money and you are repaying. All right, now you are saving. All right, on the timeline, this is what you can see. We are making amount X, we are paying X at regular intervals until the last payment is made. The formula works to the last payment. All right, and then from there, that's where our future value would be obtained. All right, moving on. The future value annuity formula. Now we know what future value is. Now we have to look at the formula that governs our workings around the future value. All right, we can use the following formula to calculate the future value of an annuity. There is the formula there. F represents the future value. All right, in that I put F sub V. All right, so F sub V represents the future value. X represents the equal and regular payments per period. If you are paying 500 every month in that investment account, you are investing 500, so X is that amount, right? N represents the number of payments. You see now, N is different from the N in grade 10 and grade 11, because in grade 10 and in grade 11, N represented the duration with which the amount will stay in the account, all right? But here, N represents the number of those payments that you are making, okay? So you need to be very, very careful here. N is the number of payments that you are making. It does not represent the duration of the investment period. It represents all the payments. So if there are payments that are skipped, if you're using the formula, you cannot include those payments. All right, so N represents the number of payments, and then I is the fractional interest rate as a decimal. All right, the future value annuity formula is used whenever payments are made, small amounts are made, and the total, the large amount, is accumulated or collected later. Which means when you use this formula, you expect that the money that you get, all right, FV should always far supersede what? X. It should always far supersede X. That is the money that you are paying each month. All right, so you should get a lot out because you were investing. All right, so when do we use the future value formula? We use it when working with retirement annuities. All right, when mommy or daddy or anyone for that matter, uncle or anyone for that matter who's working full time, all right, they have what we call a retirement annuity. There's a portion of money that is taken, all right, from their salary, and the employer contributes a certain amount of money. We put it aside for what? For pension, all right, so that when they retire, they have something, all right, called the pension money. All right, so by the times you can set up your own retirement annuity, you are working, you then go to a financial institution, you say, I want to have a retirement saving, so I want to save 500 per month. I am going to retire when I'm 60. Please save this money for me every month. When I'm 60, I would want that annuity paid back to me. It works in different ways. All right, savings account for education. Some of your parents have actually saved money for your education, so that when you go to tertiary at least there is some money that is there to start your tertiary education. Sometimes you can save for a holiday. You want to go on a holiday with your family. You save money now so that you go in maybe in a year or 2 years time. All right, so you are saving money for the future. That is why we are saying it's future value. Even with retirement, you are 30 years now, you want to retire at 55, so you are saving money for the future. So it's governed by future value annuity. Also with sinking funds, they work in this way. You have a company saves, uses, maybe let's say it's in agriculture. You have a farm and you have tractors that you use to run that agricultural farm. So you get that now you want to save money for the future, so that in future when you when this tractor reaches its useful life, maybe this tractor now has to be replaced, at least you have money that you put in aside for you to be able to buy a new tractor in future. So you are saving money for the future in a special fund called a sinking fund, which I think your teachers have zoomed more into it. All right, let's move on. The future value annuity example. All right, now let's start with examples. Now, what is key here is that with all the examples and activities that we are going to do, we are going to draw a timeline. Okay, I need you to understand that when your teachers draw timelines for you on the board there, they are not doing it for themselves. They can solve these finance problems without timelines. They are doing it for you so that you visualize and you are able to solve. So it's important that you copy those timelines down. I've seen at times you just write the solution. No. Copy that timeline. Understand how the money worked in that particular timeline. When you solve the problems yourself, draw your own timeline. There are no marks for the timeline. However, if the timeline is there, it guides you. It ensures that you don't make mistakes. All right? So let's look at this Mr. Lee problem. Mr. Lee opens a savings account for his son's education. He deposits an amount of 600 at the end of each month. So you see now the development of that annuity. 600 at the end of each month for a period of 10 years. The interest rate is 12% per annum compounded monthly. Calculate how much Mr. Lee would have accumulated at the end of 10 years. Let's try to check what Mr. Lee will get after 10 years for his son's future education. Let's look at the power of compound interest here, the power of future value, the power of investments, right? We are doing this topic so that we also assist you to make good and sound financial decisions in future, and also to assist your parents. Okay, now solution. Let's look at this. There is the timeline. You see, he's investing each month is 600. T1 represents the first month. T2 represents the second month. It goes on and on. You see, I'm not going to show all the months there. It goes on and on to T119. Where is this 119 coming from? It's 10 years and we are doing it monthly. So you are going to use your calculator to check how many months are there in 10 years. You say 10 times 12, you get 120. This is where this 120 comes from, all right? So he's making those payments there, all right? There is the payment at 119. There is the payment at 120. Remember, the formula works to the last payment, all right? So now from here, we can then use our formula. All right, let's look at the number of payments. Remember, N represents the number of payments. How many payments are we making? We check the upper limit, which is the last payment that we've made. Subtract the lower limit because we've been investing every month. 120 minus the lower limit 1 plus 1. All right, because this one is also included. So we get that it's 120 payments. All right. 120 payments, not 120 investment periods, but payments that we make, because X represents the number of payments, all right? So now let's go to the formula. This is the future value annuity formula. F sub V is equal to X into 1 plus I to the N minus 1 divided by I, all right? So now, substituting, we substitute 600, all right, which is the payment that is made, all right? And then it is made monthly, all right? We are compounding monthly, so which means this 12% is converted to a fractional rate, which is 0.12 divided by 12, all right? The 12 that we're dividing by is because we are compounding monthly. And then the number of payments here at the top is 120 payments. Subtract 1 and then divide by I as well. Now, remember, good people, even if you don't understand to solve a specific finance problem, you have things here like your fractional interest rate. You can see this conversion here can give you a mark. All right. It's things that you know that you've done. It can give you a mark. So you cannot leave these questions unanswered. It is not acceptable to leave these questions unanswered because there are things that can give you marks that are in the statement. All right. Moving on. If you put that in your calculator, you get 138,023 rands and 23 cents. Okay. Now, if you look at this, you see he's investing just 600, but because he's doing it consistently for 10 years, he's getting 138,000. So when his son goes and starts tertiary education, he will have 138,000 to begin. All right. It might not be enough in nowadays because of the expenses, or rather because of how expensive tertiary education is, but it is a start. Okay, it is a start. So it's important that those investments are made. All right, I'm moving on to example 2. All right, suppose that at the beginning of the month, 2,000 is deposited into a bank. At the end of the month, a further 2,000 is deposited, and a further 2,000 at the end of each month for 5 years. So we're doing it at the end of the month, all right? But now we started at the beginning. So that should give you something here to think about, all right? Suppose that at the beginning, so there is an immediate payment, all right? It's unlike in this previous problem here, where we started putting money after T1 at the end of what? The first month. All right. Here there's an immediate payment that is made at what? At T0. All right. There's an immediate payment. All right. If the interest rate is 6% per annum compounded monthly, how much money would have been saved after 5 years? All right. Let's check now. Obviously, the timeline should be at the center of our problem solving here. Now, if you check here, because there's an immediate payment, that was supposed to then indicate here that there's a 2,000 here. All right? The immediate payment. Now, what does that change? It changes the number of payments. All right? Because you have an additional payment that is made at T0, the number of payments become now upper limit minus now the lower limit T0, 60 minus 0 plus 1 because 0 is included, all right? So this takes us towards 61 payments. So 61 payments. So you can see that if you are making an immediate payment, then the number of payments there are out to be more, all right? All right. So we have that it's 61 payment. There's one additional payment, all right? So now let's look at the formula. Remember, N represents the number of payments. We're still saving money for the future. So this is governed by the future value annuity formula. If we substitute in our formula, 2,000 represents the amount that we are saving, all right? 0.06, that is the interest rate, which was 6% converted to a fraction, 0.06. Div 12, because we are compounding monthly, all right? N represents the number of payments, which we've calculated here as 61, and then divide by I there, which is the fractional interest rate divided by the regularity of the compoundings, all right? So we get that this is 142,237.76 cents. So you can see that if you are investing 2,000 just for 5 years, the power of investment here, you get out 100 and something thousand. Sometimes they can ask you to calculate the interest. How are you going to do that? You are going to check the 2,000 that you are paying. You check how many payments, 61. So it means that you would have paid 122,000. Right? But you are getting 142,000. So the difference between the two, this subtract that will give you what? The interest that you got out of this. All right. So if I can actually check it in the calculator here, 237.76, I can see that the interest is 20,000. 237.76. So you've earned interest of 20,000 in 5 years. That is the power of investment. All right, let's move on. Variations to the future value annuity formula. There are some variations, all right? Sometimes there are things that we do to the formula to alter it or to trick you. The timeline here also would assist you to see those variations, all right? Now, I'll just speak to some of the variations, all right? I'll speak to those variations that you can see, and then from there, I'll just pick any two of these and explain them in detail. You will be able to do the rest on your own, all right? You will be able to do it on your own. You just need to understand what is happening, all right? These are examples of some variations. Same money is invested in equal intervals for a certain period, but instead of being withdrawn, it is left in the account to grow some more time without making any further payments. Let's say in the previous example, you've invested it for 5 years, right? And then maybe after 5 years, when you have to take the money, you say, I don't need it now, okay? I don't need it now, but I don't want to make any further payments. I'll take the money after 8 years. You leave it in the account. So it continues to grow, but now it's no longer governed by what? By annuity, because the regularity of that payment has been removed. You are no longer paying that 2,000 every month. However, the money is still in the account. So it is still governed by interest, compound interest, but it's not the future value. So you need to know how to work with it, all right? Amount greater than or less than the annuity is paid into the account, all right? So you need to know how to deal with that as well. Same amount is being invested in equal intervals for a certain period, but no payment is made at the end, all right? So instead of, if you are having your payments here, X, 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 and you are taking your money here, future value, you don't make this payment, all right? So now, this particular problem here would be a variation. You will need to get your future value here and grow it by a month using compound interest. So this is almost the same as this one. It's almost the same in terms of variation, but it's different context. But the adaptations that would be made to the formula would be the same. All right. Equal intervals, monthly, quarterly, half yearly, etc. All right. Equal intervals are done monthly, quarterly. It's not a variation, but it's different compounding periods. Let's say you are investing and then you do it monthly for some time, and then after that, the regularity, or rather the interest rate, is now quarterly. So you need to convert it back to monthly. So this is not a variation, it's just different compounding periods. All right, some of the variations shall be explained in the slides below. All right, I'll explain just a few, maybe two of them. All right, let's check which ones I'll explain. Same amount is invested in equal intervals for a certain period, but instead of being withdrawn, it is left in the account to grow for some more time without making any further payments. Now, let me explain this in a practical context. Let's say when my son is born, I decide to invest money, right, with an assumption that when he is 18 years old, he would be in matric, right? When he's 19, he will start tertiary life, all right? So I invested for 18 years. When he's born now, I'm putting it up for 18 years, all right? Now, let's say that in between his schooling life, all right, he might have gotten sick and not completed 1 year, all right, and had to repeat a grade, or he might have not met the pass requirements for a specific grade, all right? So it means that he is no longer going to pass matric at 18 years. He's then maybe going to pass it at 19 or at 20, depending how many years he got disrupted, or depending on how many years he did not meet the pass requirements to be promoted to the next grade. So you find that he goes at tertiary on 20 years. So after 18 years, I stop paying, all right? I stop paying. And then I say, all right, let me leave this up because this is not my money that I have to use. It's the money that I saved for him. All right. So he will use it whenever he matriculates. All right. So I decide to leave it in the account until he matriculates. If he matriculates at 20 years, it means that now I've saved the money, let's say for 18 years monthly, 18 times 12, I've saved the money for 216 months. All right. T0, T1, I've put in the amount, let's say the amount is X. All right. So at 216, that is after 18 years. This is my 18 years, all right? I decide to say, okay, because he did not make it in 18 years, maybe he made it 2 years after 18, all right? Maybe he's in matric 2 years after 18 years, all right? So a further 2 years. But remember the future value is here, right? But this amount is not withdrawn, all right? Not withdrawn because of the challenges that I've just shared with you, but is left there with that financial institution, whichever financial institution that I'm using. I leave it there. I say, let me wait for him to first matriculate, all right? So that money should earn further interest, but that interest is not annuity based because I'm no longer, you see, at 217, 218, I'm no longer putting in any amount, all right? So what happens is that for the first 18 years, I have what? Future value annuity. But for the next 2 years after that, I have compound interest. So what's going to happen to the formula is the following. You have your future value, right? You have your accumulated amount, A. It would be A. Let's say the amount that you're going to take out here is A. That amount would be the future value, right? The future value that is here, all right? But that future value will earn additional interest. It will earn additional compound interest because it's still under the compounding. It's still subjected by the same interest rate, all right? So this money here that I would take out here will further grow by 24 months, all right? So I would have that this would be 1 plus I to the 24 because it will grow a further 24 months. All right. So what is the future value? It is X, all right, into 1 plus I to the n minus 1 over I multiplied by what? 1 plus I raised what? 24. So this is to account, this here is to account for what? The interest. Interest gained for what? For the further 2 years. So that is the variation that we are making to the formula. That is the variation that we are making. I need you to understand what is happening so that you'll be able to solve problems. You see, I did not solve any problem. I just presented the possibilities. Okay? So it's important that you understand those possibilities. Now, let's look at another variation. I said I'll just do 2. All right? Then we move to present value. Let's look at another variation. Amount greater than or less than the annuity is paid into the account. All right. Let's say you have an annuity, 500. All right. For 5 years. Let me take it 4 years, which is 48 months if you are compounding monthly. All right. T48. All right. T47. T46. Okay. T1. T2, T3, T4, T5, T6. Okay, let's say you are investing 500. All right, you start, let me have my T0 here. You start here, 500, 500, 500, 500, 500, and so on. All right. But now at T0, when you open the account, you open it to, you say, I am making an immediate payment of 2,000. You see, this amount is greater than the annuity. If you like, you would have said 300. When I open the account, I'm just going to put in 2,000, right? And then after that, I pay 500, 500, 500. Where is the annuity formed? The annuity is formed when you start paying the same amount at regular intervals. So that is where we develop the annuity. But this money is not part of the annuity, not part of annuity. All right? This money is not part of the annuity because it is greater than the annuity or less than the annuity. How do we deal with that? How do we deal with that? So now what we need to do is we look at the money that forms part of the annuity. So our future value, if it happens that we are withdrawing the money here and we say that is A, all right? Remember, the annuity stops here, so that is where we get F. All right? So you would agree with me that the accumulated amount would be F. That would be F sub V, which is the future valued money, all right? Plus, all right? Plus whatever this amount is, all right? Plus this 2,000, all right? But this 2,000 was also subjected to this timeline. So it was subjected to the interest rate. All right. So this 2,000 is also going to gain interest. For how long? Remember, in compound interest, N represents the duration with which the amount stayed. So the amount stayed there for what? For 48 months if I'm compounding monthly. All right, this is the interest rate. So we are now having a new variation where this future value as a separate formula, this future value is going to also have an amount adjusted to it. All right, so we get that this money that you're going to get, which is A, will be the future value of the annuities that were made. All right, these are the annuities that we are talking about, the 500. All right. However, there's an amount there that is not part of the annuity, but it is in the account. So that money should also be grown using what? Compound interest. We are on compound interest here. So this money will gain interest for that. So for the future value, you'd use the formula X into 1 plus I to the n minus 1 over I, right? This is for future value, plus now you'll have this 2,000 here, which is 1 plus I, all right, to the power of 48 there, all right? So this will give you the accumulated amount. So that is another variation. So I will need you to go back, okay? I will need you to go back, all right, and look at some of these variations. I've just looked at 2. I put in there about 4 of them. I need you to go back and check, all right? Go back and check how you'll deal with the further variations. That is what finance is about. You need to understand what is happening. But when I was explaining it, I was using what? The timeline. So the timeline is at the center of this. All right, there's an activity here that I want you to do. I'm just going to give you 5 minutes to do this activity, dual activity. It includes some of these variations. I just want to check whether you'll be able to apply them in problem solving. All right, your 5 minutes time starts now. Right, hello and welcome back. Please remember our WhatsApp interactive line is active. You can ask questions that are based on this current lesson there. All right, let's move on. The activity that I gave you, it's about Joel saving up money to buy a car wash, a car cash, I mean. After obtaining his degree from university, he opens a savings account and immediately deposits. So it's immediate deposit of 500. After this, he continues to deposit 500 at the end of each month for 4 years. The interest rate stays fixed at 8% per annum compounded monthly. At the end of 4 years, Joel does not withdraw, all right, the amount and leaves it in the account for a further 2 years while completing his honors degree, all right? Calculate the total amount accumulated after 6 years. You see, this is a variation to the formula. Let's look at it. I think I've explained it thoroughly before. So let's just go straight to the solution. All right, the timeline. All right, if you can see, Joel immediately, so there's supposed to be a 500 that is put in here because of the immediate payment. All right, so and then if you check after what you call 4 years, this T48, that's where we get our F sub V, the future value, but he does not withdraw, he leaves it to grow still, okay? So we are going to have that variation which I spoke to you about. There is the variation there, all right? This is the, here, this accounts for what? Interest gained by the amount after the annuity has stopped. All right, after the annuity has stopped, there was interest on that amount. All right, so this is the formula that we are going to use, where N1 represents what? The number of payments that were made, and N2 represents the duration with which the amount stayed in the account after the annuity has stopped. All right, so let's go. We are now substituting. The amount made is 500, okay? The interest rate is 0.08 as a fraction. Divide by 12 because we are doing it monthly. How many payments were made? It's 48, all right? Minus 0, all right? 48 minus 0 plus 1, which is 49. So that is why we have 49 payments there, because there was an immediate payment, an extra payment made, all right? So, and then minus 1 divided by 0.08 divided by 12. Now we multiply by the interest that we spoke about that was gained for 2 years. So it stayed there for 24 months. The interest rate is 0.08 upon 12. You put everything in your smart calculator there. You get that the amount is 33,852,82 that Joel will get. So he will be able to buy a very nice second-hand car there, Joel, that he will move around with as he studies at tertiary. All right, we are moving on, good people. We get to the present value annuity. All right, present value annuity. We've done future value and we did a lot of variations on the future value. Same with the present value. There are some variations that we need to talk to. All right, so what is a present value annuity? It refers to paying back the loan by equal monthly installments. All right, if you've made a loan. All right, interest is calculated using compound interest. We also refer to a present value annuity as a reducing balance loan. Someone might think that it's only loans, all right, that we are talking about that use a present value. It's also reverse loans. I'll explain what it means. If maybe you've won, let's say you win you've won lottery, you get 2 million, and then you decide to put that money in the bank, all right, and then the bank gives you a certain amount. You ask them to give you a certain amount every month, okay? So it's like you've loaned it to the bank and then they are now paying it back to you in equal payments. So that is also a present value annuity. It's like a reverse loan. It is now the bank that has borrowed it, that is paying you back the money that you borrowed it. Okay, so that's how it works. It does not only work with you going and getting money from a financial institution and paying it back. At times you can give the financial institution money and ask them to give it back to you so that in equal payments regularly, maybe monthly, maybe quarterly, and so on. So if that happens, then it means you are having also a present value. So you need to understand it from that context as well. All right. Now, this is what I've written there. What I've just explained is what I've written on the note. The present value involves two types of loans. The first loan is when someone borrows money from the bank and repays the loan with interest. Okay, that is number one. All right. This one is number one. And then the other type of loan is where a large sum of money is invested in a financial institution, and the financial institution pays back the investor in equal amounts over a period of time. So this is number two. I need you to understand both these because both of them use what? The present value formula. All right. Now, on the timeline, all right. So on the timeline, this is what we are having. The present value is here. Unlike the future value that is at the end, the present value is at the beginning, all right? That's where you've borrowed the money, all right? And then from there, you start to pay it back now. See, you start to pay it back until you finish paying it. So, which means that as you pay it back, the balance reduces, all right? If you borrowed 500,000 and start paying 10,000 every month, then you expect that the month that you owe keeps on decreasing until you finish that loan. So we have possibility here of bringing out what we call the outstanding balance. All right, that is why in present value there's something called outstanding balance. Okay, let's move on. The present value annuity formula. Let's get to the formula now. We can use the following formula to calculate the present value of an annuity. This is the formula. You can see now there were variations. It is in the formula sheet. P is the present value. X is the payment, equal and regular payment. N is the number of payments. I is the fractional interest rate. Now, this is very important. There must be a 1-period gap between the time when the loan is granted and the first payment is made for the formula to work. You can see here that gap is needed, all right? Very, very important, okay? Now, should be a 1-period gap for the formula to work. If it's not there, it must be created by all means necessary using correct mathematical techniques, okay? We use the present value formula when working with repayments of home loans, all right? Student loans, vehicle loans. When your parents are paying back the home loans, then that is present value annuity. Student loans, if maybe you've taken a loan for your son's education, your daughter's education, when you pay it back, student loan, present value. Vehicle loans, the cars that we have, if we bought them using finance, then we need to pay back, all right? The present value annuity, example 1. Let's look at an example now. Quickly go through that. Menzi buys a house and takes out a loan of 1 million. All right. He repays the loan over 25 years. So it takes Menzi 25 years to repay this loan. The interest rate on the loan is 8.5% per annum compounded monthly. Determine then the monthly repayments on the loan. Assume that the first payment starts 1 month after granting of the loan. This is the 1-period gap that we are talking about, all right? 1-period gap for the formula to work, okay? 1-period gap. So calculate the total amount of money required to repay the loan, all right? Let's go now, all right? Total amount of money required to repay the loan, okay? Let's look at the solution. Starts with our timeline, all right? Menzi starts paying X here, X there, all right? That's the money that Menzi starts paying back. He's taken the loan here. That's when the loan is granted, all right? It's granted here. And then there's this 1-period gap, okay? There's that 1-period gap, okay? and then from there he starts paying amount X, all right, until he finishes the loan. Okay, now let's look at the solution set there, the steps. All right, we are using P sub V because we are now talking present value. All right, so we use that formula from the formula sheet. Okay, and then we substitute. All right, we need to know how much Menzi should be paying each month to be able to finish the loan in 25 years. So we want to calculate X. All right, so how many payments will Menzi make? It will be 300 upper limit, lower limit, minus 1 plus 1, because this is included. So this becomes 300 payments. All right, so that's where the 300 comes from, but from the formula it should be negative because this is reducing balance. All right, this is reducing balance. Okay, and then the fractional interest rate there, then we calculate X, we get that Menzi should be paying 8,052 rand 27 cents every month to be able to cycle this loan. All right, so that's what we have there. I'm moving on. All right, that's just a basic problem. I'm moving on. Let's check the interest now, just for interest's sake. Let's check the interest. You see the repayment. All right, Menzi borrowed 1 million, but he pays back 2,415,681 rand and 25 cents. So if you check the interest is 1.4 million. All right, so you can see that these home loans, all right, you end up paying double the amount that you borrowed. All right, so that is what is happening. That is how the financial institutions here are ripping us off as far as home loan repayments are concerned. So in future, when you guys want to buy your own houses in future, do think about this. All right, do think about how you can negate this. All right, do think about how you can negate it by putting up a deposit. All right, or by paying more than the money that is required there, so that you can kill the interest, right? So that you can be able to make sure that you minimize the interest so that it does not go to 1.4 million. All right, so these are things you have to think about as you make decisions based on your finances in future. All right, so that is why we do this topic, so that we can make sound financial decisions later. We don't just do it for fun, all right, or because it's in the curriculum. We do it so that we are able to make sound financial decisions in future. So do think about that. Do look at it. Do look at the repayments and see how much you'll be losing, all right, and how best can you negate it. It's very, very important. Okay. Now the amount needed, that is I've just multiplied by 300 the repayments. They give us 2.4 million. So you can see it's what I've been explaining there. All right, so now let's look at example 2. Musa borrows 500,000 from a bank and repays the loan by equal monthly payments of 8,000 starting 1 month after granting of the loan. We are given a 1 month gap, and this is compounded monthly, so we are covered for the gap. All right, so how many payments of 8,000 will be made? All right, let's check. Now, timeline first. All right, this is our timeline. We are paying back 8,000 starting from T1. We've been granted 500,000. There is that gap. Okay, that is mandatory. All right, and then these are the 8,000 that we are paying. All right, now let's check. 500,000, 8,000 that is repaid. The interest rate, we are looking for N. So now we have to use our knowledge of logarithms. All right, so you will rearrange the formula and work out N using what? Logarithms. All right, remember you are using the log of a number, all right, to its base is equals to what? The exponent. That is to convert from exponential form to logarithmic form. You've done that when you were doing your exponential functions and log functions. So that is how we worked with this formula, all right? Then we get that n is 186,22. All right. Remember, we said n represents the number of payments, and we cannot have a fraction of payments. All right. So let's explain what this means when you get 186,22. Let us explain what it means. All right. What does it mean? It means that you have 187 payments that were made. All right. 187 payments, because we cannot say we have 186,22. There is no fraction of a payment. But what it means is 186 payments of 8,000. And there is one payment that is less than 8,000. The last payment is less than 8,000. Later in the topic, you get to do last payment. That is where you'll calculate that payment that was less than 8,000. Right? When you do the concept of what? Last payment, all right? Something that will be done later. Last payment. So this tells you that there's a last payment that was made, all right? We'll look at it when we look at last payment. Deferred annuities, all right? Deferred annuities. That is where now you combine present value, annuity, and compound interest. Let's see what happens there. When the first payment of a loan is made more than one period after the loan was received, we refer to the payment as a deferred annuity. All right? If the period is not one period gap as we indicated. Note that the present value annuity will still be located one period before the first payment. Very, very important. So we apply compound interest to the loan to move it to the same point on the timeline as the present value of an annuity. It's very, very important. It's key. If you don't have a one period gap, then you need to have the variations. This is the variation to the formula. All right, let's look at a practical problem. Okay, let's look at a practical problem that would govern that deferred annuity. Siamo takes out a 20-year loan of 100,000. She repays the loan by means of equal payments starting 3 months after granting of the loan. You see now, Siamo is paying monthly, and now he starts 3 months after granting of the loan. So we do not have a one period gap, 1 month gap. Instead, it's 3 months. How do we deal with that? The interest rate is 18% per annum compounded monthly. Calculate the monthly payments. Okay, so this is just a variation that I will need you to be able to work with. Okay, let's look at the solution. We take it to the timeline. The loan amount taken is 100,000. All right, but Siamo starts paying after 3 months. All right, so we no longer have that one period gap. Remember, we need to create a gap between when you start paying and when the loan is granted. So the loan was supposed to be granted there. All right, the loan was supposed to be granted there, but it is not. It is granted at T0. So this loan is going to grow for 2 months. If you don't pay, the amount grows. All right, which means that when you start paying, you are not paying 100,000 that you borrowed. You are paying more because of that 3 months delay. All right, so you need to look out for those things. Sometimes when you buy vehicles, they tell you that you'll start paying after 3 months. All right, but if the loan is granted now, it means it's going to accumulate interest. It is not to your advantage. All right, because the 100,000 that you borrowed now, 2 months down the line, is no longer 100,000. So you'll be paying off more. All right, so you need to look out for those things. So now, if you do that, then you need to have that one period gap. So you'll grow the loan by what? By 2 months. All right, so now this would be at T2, you'll have the new loan amount. So that would be the amount that would be subjected to the repayment. Let's check. All right. So now check what is happening. The loan amount, the 100,000, it will grow for 2 months. All right. So that is how we varied the formula. The 100,000 will grow for 2 months, and then you take that to the annuity. when you start repaying it. Okay, so that's what we have to deal with. Okay, so you see, we take the amount, the loan amount, it grows for a further 2 months. So this now represents what? The new loan amount. That is the one that would then be subjected to what? To the annuity. All right, so if you perform your calculations there, you rearrange, you make x the subject of the equation. All right, that's what you get. Multiply there, take this, you multiply that side, and then you divide to make x the subject. You get that now your x now is going to be 1,591 rand and 35 cents. So that is the money that Tsiamo has to repay. But this is important in terms of the variations that were made. All right, good. Okay, now let's look at the outstanding balance. I think this would be the last concept that we look at for the day because of time. All right, as you repay the loan, what happens is that the amount that you owe keeps on reducing. So we want to know at a specific period of time how much you owe. Maybe if you want to settle, so you can then say, how much do I still owe? So you need to know the outstanding balance. So in the statements that are provided for the loans, they always indicate that, okay, you've paid this amount, this is what you were owing after paying, this is what you now owe. That is called the outstanding balance. Okay, we need to know how to calculate it. The outstanding balance on a loan at a given moment is the amount that has to be paid to settle the loan. Two methods can be used to calculate the outstanding balance. Okay, method one, we are going to take the loan with interest to date. All right, the date that you want to know the balance minus the repayments with interest to date. So we are going to take the loan amount that has gained interest, we subtract the repayments that you've made also with interest. Okay, so it is now Bn, which is A minus F. So this Bn here is A minus what? F sub V. All right, method two, the present value of the remaining payments. All right, the balance outstanding after n periods can be calculated using what? We take now the number of payments that are remaining. Take the present value of the payments that are remaining. So we are going to use present value formula here. But here we use both compound interest and future value. So those are the two methods. Please use one and stick to it. All right, do not use both. All right, take one and stick to it. Okay, I would use method one because the n there is not a problem. With method two, it is much easier. It's one formula, but the problem is that now these are number of payments remaining. So if there are commas, there are small values, the numbers after the comma, you need to take all of them to be accurate. All right, so let me take you through the last example. All right, this last example, we are going to do it using both the methods. All right, so I'll take you through just to show you that both of them will give you the same answer. All right, Kulego buys a house and takes out a loan of 1.2 million. He repays the loan over 20 years by means of equal monthly payments of 11,580.26 cents, starting 1 month after granting of the loan. So the 1 period gap is taken care of. The interest on the loan is 10% per annum compounded monthly. Calculate the outstanding balance on the loan after the payments have been made at the end of the 5th year. All right, so let's see. Using method one, let's bring in the timeline. All right, we want the balance after what? After 5 years. All right, so in terms of months, you would say 5 times 12, it's 60 months. So we want B60. All right, so now the money that was granted is 1.2 million. He starts paying here. It's 11,580. Made a mistake here. This is the amount that should be taken there, 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 and there. It's not 11,000. It's 11,000 and a couple of rands there and cents. Okay, so let's just make that a change there. All right. So now, if we use method one, this is what we should be doing. All right, it's the loan including interest. So we take this 1.2 million, it gains interest, compound interest for the duration of the period, subtract what you have paid. So you're going to get the loan amount, subtract what you've paid, that would be the outstanding balance, all right? So now let's check. It's 60 because they want the balance after 60 months. So it's 60. So we're going to be using 60 there. So it's easy to calculate the number of payments because it will be 60 minus 1 plus 1. So it's 60 payments. So it's easier then because you are using both the compound interest for the loan and the future value of the amounts that you've been paying. All right. So if you calculate that, it takes you to 1 million. All right. 77,629 rands and 29 cents. So this takes you back there to say, look, you borrowed 1.2 million. After 5 years, you've just the balance is still 1 million. So you just paid off just a fraction of the money because of the interest that it has. All right. Let's look at method 2. Method 2, we are going to be using what? The outstanding balance, using what? The remaining payments. Okay, so we bring in the timeline. Still here, we have to change these monies to this one. All right. Okay, and then now we want the balance after 60 months. So we're going to check how many, all right, payments remaining. So we have to get how many payments still remain or outstanding. All right, so let's check quickly here. We are using the second method, number of payments remaining after 60 months. How many payments are remaining? It's 240 in total, minus we've made 60 payments. So 180 payments still remain. All right, so you see the end there is a trick because it's the number of payments that remain. Interest rate is the same, all right? So let's see the final answer there. The final answer is the same as the one that we got in the previous one. All right, so the answers are the same, but you are using an alternative approach. So it's important for you to know how to use these particular methods to calculate the outstanding balance, but please use one and stick to it. All right, good people, we've reached the end of our lesson for today. There were other things that we were supposed to have done, the last payment, all right, and the activity that involves the last payment, but I hope that whatever that we've done would be enough to actually make sure that you guys are able to work with the last payment, and then your educators will assist you as well with this last payment. All right, so I am concluding today's lesson now. All right, together with the missed payments. All right, so we were left with the last payment together with what? The missed payments. Okay, so please do go back and look at those things. Very, very important that you do. All right, very, very important that you do as you prepare for your examinations. All right, missed payments, last payments as well. They use the concept of what? Outstanding balance. So if you understand your outstanding balance and you understand the variations to the formula, it should be easy for you to be able to work on that. All right, so this is the summary. We've worked with the future value, we've worked with the present value. Those are the two formulas. We've worked with deferred annuities as well as the outstanding balance. So thank you very much, you guys. So let's preview the next lesson. The next lesson would be next week on the 30th from 2:30 to 4. We'll be revising grade 10 and 11 statistics. Okay, so that is just statistics, grade 10 and 11 revision. That's what we'll be doing next week. All right, thank you very much for tuning in. Please take care of yourselves and take care of each other and practice mathematics. Goodbye.